Good morning, afternoon, or evening, everybody. Welcome to the Improving the DAAC User Experience with Cloud-Based Capabilities Earthdata webinar. This is your host, Jennifer Brennan. I have 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. First, I will begin with a few webinar logistics. To ensure the best audio experience, participants have been placed in silent mode. But if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the lower right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted to our online Adobe Connect webinar catalog, as well as to our NASA Earthdata YouTube channel within a few days of completion. And what I'll do is, once we have completed today's event, I will, and the post-processing is complete, I will send an email to all registrants with recording links. Excuse me. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstration, and an additional 15 minutes for the question and answer period. All right. Right now, let's go ahead and pull up today's agenda. Our speaker for today is Dr. Jeffrey Stano, who is the DAAC scientist at NASA's Global Hydrology Resource Center, Distributed Active Archive Center, or GHRC DAAC. We will also have a Q&A panelist during today's webinar, Will Ellett, who is the Principal Research Scientist with the University of Alabama in Huntsville's Information Technology and Systems Center. And he also serves as the GHRC DAAC Operations Manager. Okay, so everybody should be able to see the agenda. Dr. Stano will begin today's webinar with an overview of the GHRC DAAC and the data holdings. And then from here, we will transition with an overview of GHRC's cloud transition efforts and the rationale behind this move. Next, we will quickly discuss the implementation of Earthdata Pub, and then from here, we will transition to an overview of the Field Campaign Explorer tool, followed by a live demonstration for this tool. After our speaker is finished with this presentation, we will move to a final optional set of polling questions, and generally we'll give these questions 3 to 4 minutes or so, and from there we'll transition directly to the optional end polling questions. Excuse me. From there, we'll transition to the Q&A period. All right, depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes from end time for those of you who wish to or are able to stay on the line, but we will have a hard cutoff of 3:15 p.m. With that, it is my pleasure to introduce today's speaker, Dr. Jeffrey Stano. Jeffrey, and I will pull up your slide deck here. Okay.
Well, Jennifer, as you pull those up, thank you very much for the introduction. And also, I would like to thank everyone for who is here in attendance today. I appreciate you taking time out of your schedules to be able to hear a little bit about what we're trying to do in terms of improving the DAAC user experience with cloud-based capabilities. Overall, the presentation is going to cover a little bit of work that we're doing here at the Global Hydrology Resource Center. And we're going to kind of show a couple of examples that have also included some of the cross-DAAC applications that are going on. Overall, from the discussion and from the presentation, we're going to aim more for, again, the user experience, not so much on the technical side, but just kind of show what we're trying to do and what makes going to the cloud useful for end users. So as we'll get started here, I'll move on to our next slide at this point. First of all, I want to acknowledge everyone who's been involved with this project. While I'm the presenter, there's been a lot of effort that has gone into this across the board, all the way from our DAAC manager, who originally helped create the Field Campaign Explorer, which we will discuss later and demonstrate later today, all the way through the various developers, scientists, and other architects of the project that have gone through. And so I would be remiss not to thank them for all their time and effort that has been put into it to get us to this point to give the presentation today. So thanks to each of them, and I'd be happy to kind of show a quick outline, as Jennifer mentioned. So overall, today's topics, I want to focus on what is the Global Hydrology Resource Center. There might be some individuals might not know exactly what we do or the DAACs as a whole, so I want to give a little bit of feedback there. And then I'll talk a little bit about our cloud transition and why GHRC and the other DAACs are beginning this transition process into the cloud. There's going to be some advantages to doing this, and also how does that relate back to, again, the user experience. I'll talk a little bit about our cross-DAAC collaborations, both with individual DAACs and also with our parent organization and what we've been trying to do. And then lastly, I'm looking forward to showing this. I will be showing a demonstration of our Field Campaign Explorer. And this has been something that's been kind of in development for a while, and so I'm really excited to finally show a public version of this at the end of the presentation. This will be a live demo. So for the next step, like I said, we'll start off with an overview of the Global Hydrology Resource Center Distributed Active Archive Center. First of all, a little bit about myself. My name is Jeffrey Stano. I am working as the DAAC scientist, and so a lot of my work is involved in the outreach and science background activities that occur at GHRC. In many ways, I kind of consider my role a little bit like a translator. We'll be working with a lot of, the GHRC has a lot of computer science individuals, in addition to a number of atmospheric science individuals. The effort is both internally and externally to help try to kind of draw all that expertise together to develop the tools and procedures and the other items that we bring together for the public to use. My overall background has been in applications research. Primarily, I worked in lightning safety and severe weather decision support, and in my past life, I was serving as the satellite liaison for the geostationary lightning mapper. So working with lightning is always exciting, so if you want to really get me talking, you can start asking some questions about lightning later on. Now about the DAACs themselves. The DAAC stands for the Distributed Active Archive Center. Each DAAC, we are part of NASA's Earth Observing System Data and Information System. And as you can see on the map on the right here, there are 12 DAACs distributed across the country. The Global Hydrology Resource Center, we are located in Huntsville, Alabama. Now, primarily, our role, both at GHRC and the other DAACs, is that we're working to process, archive, document, and really help distribute NASA Earth science data. The effort is to focus both on past data and Earth observing satellites, but we're also making sure that we're looking forward to new missions that are coming down the road so that we can start making sure that the infrastructure is in place to be able to display these data and to make sure they're available to the user community. Now, GHRC itself, as I mentioned, we are located in Huntsville, Alabama. That is the home of the NASA Marshall Space Flight Center. And so the GHRC DAAC is a collaboration between NASA Marshall Space Flight Center as well as the University of Alabama in Huntsville. So it's really kind of interesting to have that kind of dynamic. We do a lot of work with NASA, but we have the opportunity to rely on the expertise that we have at UAH to kind of help promote the projects that we are working on. Now, overall, GHRC subscribes to the ESDIS vision of what we're trying to do with NASA Earth science data, and that is to make sure the data are free, open, and interactive to the user community. We also want to make sure that they're interoperable and accessible to everyone. So that's a lot of the work that we do within GHRC and all of the DAACs for that matter, to trying to make sure that all of the data that NASA is generating for Earth science is available for others to do research on. Now, overall, in terms of the GHRC mission, and forgive me, I'll read this a little bit directly here, is to provide a comprehensive active archive of data and knowledge augmentation services with a focus on hazardous weather, its governing dynamical and physical processes, and associated applications. So in short, what we're trying to do, we want to be more than simply kind of a repository of information. We want to use expertise with the scientists that we have in the program to help users be able to access these data and use it for their own individual research. Now, like all of the DAACs, GHRC has a couple of specific focuses, and we'll talk about that in a couple of slides here. One of those is working with lightning data. Once again, as with other data sets, we're working to ingest, archive, and do product generation for all of these individual data sets. GHRC has been recognized as the National Lightning Archive, so this is pretty much one of our primary roles as a DAAC, working as the repository for all of NASA's lightning data. And in fact, lightning data is one of the most popular data sets that we have available at the GHRC. We see that being downloaded regularly, and it's pretty much kind of 4 of the top 5 data sets that are downloaded come from the lightning data sets that we work with. Overall, we have a variety of data sets, primarily in the satellite-based realm, working all the way from the original optical transient detector, OTD, that launched in 1995, to the lightning imaging sensor. In fact, there have been two of those, one that served aboard the Tropical Rainfall Measuring Mission, as well as the current one, a flight spare, that was launched and placed aboard the International Space Station, and it's been operating since around 2017 or so, late 2016, 2017. Also really exciting for us is that very recently, we've been selected to archive the geostationary lightning mapper datasets, or the level 3 datasets from GOESR and GOES-S, or GOES 16 and 17. That's going to be a really exciting activity to work with here. The advantage of this is that if you combine the geostationary lightning mapper data with the other instruments, that gives us 25 years of satellite-based observations to look at lightning. At the same time, too, we worked with some of the operational line scan sensors from the Defense Meteorological Satellites, and that adds really another 22 years prior to that of some lightning data observations from space. So as you can see, I'm pretty excited to talk about the lightning data, but we work with a lot more than just lightning data. One of the other large things that we work with are NASA field campaigns. And we don't need to really look at all the little details, but the timeline at the top kind of shows all the various field campaigns that GHRC has been working with since our inception back in the 90s. Overall, we had a primary focus originally had been working on several of the hurricane field campaigns. And that over time has evolved into working with the Global Precipitation Measurement Mission, or the GPM, ground validation efforts. And so we've worked with a number of field campaigns to work with these campaigns and work to archive those data sets. What's interesting about that is that by working with a lot of field campaigns, GHRC has a lot of interaction with airborne data. And that kind of has its own unique quirks and uses for end users to try to work with. It doesn't quite work the same way as ground-based data. It's not stationary. But at the same time, too, it's not quite satellite-based data either. Yes, it moves around, but it moves in a much different fashion than, say, a geostationary satellite or a low Earth orbiting satellite. That's one thing we have to kind of keep in mind. And as we've been working with that, being able to work with these airborne data sets has been some of the driving force for both what we're doing in our cloud tools and moving on to the Field Campaign Explorer. Right now, we're currently working on the investigation of microphysics and precipitation for Atlantic coast-threatening storms, or impacts. So that actually wrapped up its first deployment this past March, and we'll be looking forward to another 2 years of deployments from impacts going forward. Now, for the next part of the presentation, I want to kind of start going into beyond just what is GHRC, but really why are we trying to transition into the cloud? What's the reasoning behind doing that? So I'll move here on to our next slide. And the question is, again, is why transition to the cloud? What is the importance of this? The first thing to look at is, on the image on the left, is our annual archive growth. So as we see this, we look at the cumulative archive size for not just GHRC, but all of the DAACs is increasing very, very rapidly. We're sitting at late 2020, moving into 2021, and we're expecting within just a few more years that the overall archive growth is going to be sitting at almost 250 petabytes of data. This is a tremendous amount of growth in just about 4 or 5 years. And we see that the archive growth rate is running about 50 petabytes of data per year. If we look at the image on the right, we can see the daily archive growth. 2019, 2020, we've been looking at, 2019 was under 20 terabytes a day. 2020 was moving up to about 30 terabytes a day. But as we start moving into some of these new missions that are coming up, such as SWAT and NISAR, we're expecting to be receiving data on the order of 48 petabytes of data per year. This is a tremendous amount of data. So overall, the cloud, moving and transitioning into the cloud has been the solution to try to archive and process all of these data. And it really comes to an issue of how can we work with all of the available data that's coming in with the current systems that are at our local DAACs. By working with the cloud, it's much more easily expanded to absorb all this data that's coming in. And that really goes back to the mission of what GHRC and all of the DAACs are trying to do, which is making NASA Earth science data available to everyone in the community for their own individual research. So GHRC has been working to transition into the cloud, and this has been a multi-year process. This goes all the way back to 2017, where we've been attempting to really just prototype what are we going to do by this cloud transition. And that prototype process means we're looking for requirements. how are we going to ingest the data? What's the way to kind of go forward with this? What's the workflow going to look like? Well, as we move forward by 2018, those questions are beginning to get answered, and we start moving into the migration process. Now we're getting some hands-on training for our developers with a system called Cumulus, as well as the AWS environment or the Amazon Web Services. That's kind of the cloud service that the DAACs are working with. And we start kind of testing out those workflows. How do we start getting data from the GHRC local archive and start getting that into the Earthdata cloud system? By 2019, GHRC was selected as the pathfinder for all of the DAACs to transition data into the cloud. And this has been really kind of an exciting process because here we're developing workflows for data publication. And at the end of 2019, we were able to move all of GHRC's data sets into the cloud. And so this is the first opportunity to do this. And so GHRC was pretty much the first DAAC to get all of its holdings into the cloud. Now we're in 2020, and the effort here has been focusing on operations. So we're doing a little bit of a hybrid process right now where we're still publishing data on our own local systems, but also publishing in the cloud. And this is really to start kind of getting us to go from that prototyping and Pathfinder standpoint to get us into the actual everyday operations. And the goal is to be prepared for 2021 when we will be working exclusively in the cloud and not doing this hybrid approach. So the question that comes down to, what are the benefits? Obviously, there's a technical benefit for the DAACs. We have the ability to more easily expand given the amount of data that's coming into all of the DAACs. But then the question comes down to, what's the user experience? How does that help you as the user, both as a data provider or as a data user? Well, overall, at minimum, we are working to make sure that the user experience is similar for all existing GHRC users, and again, for all DAAC users. If you want to look for data, you can still get data across from GHRC's Hydro system, which is now beginning to link to the Earthdata Access, which is the data in the cloud. We're also working on new tools, such as a bulk downloader, to really make it much easier for you to get data down from the cloud into your local system. That way you're not having to try to click on individual files one after another. At the same time, too, other tools that we're looking at are the Field Campaign Explorer, which we'll do a live demo on in a little bit, as well as some of the Lightning tools that GHRC has developed for the various Lightning datasets that we have. However, the cloud does offer some benefits above and beyond what are currently available at both GHRC and the other DAACs. One thing that you can potentially do is you don't necessarily have to download the data. If you can operate in the cloud, and this is one thing, this is pretty much a presentation all on its own right, working with teaching users how to operate within the cloud, you can actually start doing analyses in the cloud. You don't have to worry about trying to download it onto your local system. You can just operate on that cloud-based system. Also, that might help with some of the cross-DAAC applications. So instead of trying to find data at GHRC or Goddard or the LT DAAC and having to download it individually, you can basically go onto this Earthdata search within the cloud and get the data sets and operate from there. Also, what we're trying to do is make sure there's a common data publication tool. So it's easier for both product developers to publish their data with all the DAACs, as well as for access for data users. And I'll talk about that in the next couple of slides. So this next portion right here is really just a couple of minutes to discuss kind of these cross-DAAC collaborations and also working with Earthdata Pub. And I'll kind of move into that right now. And the first thing I wanted to talk about, this is kind of a bridge between the two topics. Why are we trying to move into the cloud, as well as trying to work with the Earthdata Pub system? And so what I want to highlight here is collaboration between GHRC and the Goddard DAAC. And as I mentioned in the previous slides, working with a cloud-based archive really offers an opportunity for users to access data from multiple DAACs. It's a great kind of cross-DAAC platform. So as I mentioned previously, you don't have to worry about downloading data to your local system. You can actually start doing that analysis in the cloud. It's also a nice ability to scale what you need. So you don't have to worry about, okay, I only have so much space on my hard drive. How am I going to handle all these large data sets that are coming in? So what GHRC and Goddard are working to do is we're going to try to do a very focused initial effort. And that's working with two basic data sets. what I want to see is that we'll work with, from Goddard, the Integrated Multi-Satellite Retrievals for GPM, or iMerge. And we have a quick little sample image up in the upper left here. From the GHRC side, we'll be providing the Global Precipitation Measurement Validation Network, or the GPM VN data from GHRC. And here's just kind of a sample image of one of the precipitation data sets that are available from that. Overall, the goal with this is that we want to start demonstrating what are the cloud advantages to users. And as I mentioned, one of those things might be the accelerated science. It should be easier to access the data, not just from one DAAC, but from multiple DAACs. Also, what we're trying to do at this point is to look at the interface between iMerge and the GPM validation network. These are very different data sets in how they are stored, their metadata, and just how they're made available. iMerge is this near global gridded product, whereas the GPM validation network, it's intermittent, it's not gridded, and again, it doesn't have the same type of coverage as iMerge. And so the idea here is to kind of develop these file-based analysis tools, kind of integrate both of these data sets in such a way that you're not having to download it to your local system, but you're doing the analysis in the cloud, so you can actually start working on doing additional verification and validation for iMerge using the validation network data sets. Now that kind of starts shifting us into the next concept, which is the Earthdata Pub system. And now this is something that is pretty much coming down from the parent organization for all of the DAACs, the Earthdata. So the challenge that we face, and this is something that will affect end users, both product providers or data providers, as well as data users, is that each DAAC, we have an increasingly diverse number of data sets that are coming to us. And you can see that even just with the local holdings at GHRC. We're working with satellite-based data. We're working with airborne data, ground data. They all have unique issues and quirks that you need to work with. And as we get to more and more expansive missions, not only are you dealing with kind of unique data sets, that data volume is increasing across the board. So what may happen is, from a user experience, data producers, they may have issues with trying to actually provide the data to the various DAACs. And the reason for that is right now, currently, each DAAC kind of has its own methodologies and software set up for users to try to provide that data to the DAAC. So the solution that Earthdata is trying to do is that their review team has encouraged an enterprise-level collaboration. So the idea is to make sure there's a common software requirement and make sure there's some development strategies and various other cloud-based tools to help kind of unify that experience. So the idea is that we don't necessarily want to completely get rid of what the individual DAACs have already worked on in their internal workflows. What we want to do is make a simplification so that there's simplification of duplicate software tools, and it's basically one user interface for all of the DAACs. And overall, this is collectively known as the Earthdata Pub. Now, as we look at that, what is it? And I kind of mentioned this a little bit already, is that the Earthdata Pub is kind of a common cloud-hosted software framework. So it provides functionality of the existing solutions. So as I mentioned, the DAACs already have various ways to work with data. So there's Dapper, SOS, other software systems that the various DAACs use. And what this is really trying to do is try and provide a nice common front-end interface that can then work with the internal systems that each DAAC has. We want to make sure that there's common terminology and everyone really knows what needs to go into that process. So this allows the DAACs to be a little bit more flexible as well because we can work with our systems internally, but again, there's that nice common interface in front of everything. Now, what is the improvement for users? First and foremost, this is a nice unified interface for product developers. So if they have a number of data sets and they have to distribute those data sets to multiple DAACs, they're not having to worry about which DAAC is using which approach. There's a nice consistent form and a consistent experience across all the DAACs for those. Now, to kind of keep moving forward here, I'll start kind of shifting gears into kind of the last portion here, which is the Field Campaign Explorer. Now, this is a project that GHRC has worked on for a little while, And we're really excited to really start pushing this forward as this is now moving into the public space. So there will be a link for this at the very end here to kind of show what is going on. Now, so what is Field Campaign Explorer trying to do? As I've mentioned, there's a lot of variable data sets that we have to work with. And that is particularly seen within the various field campaigns that are being archived, particularly at GHRC. The data sets are ground, airborne, satellite-based data, and each one of those have their own unique forms, needs, and concerns. Now, originally, this was designed as a software system that you would download, put onto your local system, and it was built for the Hurricane and Severe Storm Sentinel, or HS3 field campaign. So it was very interesting. It could work, but again, it was not a cloud-based tool. So recently, what GHRC has been doing is we've been working to leverage work from a kind of a University of Alabama in Huntsville project called Visage to start transitioning the Field Campaign Explorer into a cloud-native tool. And so what we'll show over here is what we can do with this Field Campaign Explorer. We're going to show you during the demonstration kind of the minimum capabilities that we have already, and where we're going to start going with that. So what are some of the capabilities and uses for the Field Campaign Explorer? So what we want this to be is this is a cloud-native tool, and we want to be able to explore, visualize, and analyze our data. And also we want to make sure that this is we can work with all these diverse data sets in a common framework. Now, one question that might come up is, well, there's already the worldview system to look at various data sets, and that is a great system to work with. The difference between, say, Field Campaign Explorer and Worldview is that currently Field Campaign Explorer has a three-dimensional capability. And you can see that through here, the sample image on the left. We're seeing here's the ER2 flying along. You can see the cloud radar system observations. You see the navigation data. And we just kind of look at what is going on. And also, one of the things that we wanted to work with is that the Field Campaign Explorer has been built specifically to incorporate airborne data sets. That's one thing that has a little bit of trouble trying to get incorporated into Worldview because of kind of the unusual types of data that are being seen. You have nadir pointing only radars, you have cross-track observations, you have off-nadir observations. For some airborne instruments, like the Lightning instrument package, you're looking at the electric field values. And so you're looking at really vector observations of where is the direction of the electric field as well as its magnitude. So that's one of the things that FCX is trying to address in attempting to deal with these various different data sets and how we can start trying to link them together, visualize them, and kind of really start working with them from that point. But at the same time, too, we want FCX to be more than just a simple visualization tool. We want this to be interactive. So we want to be able to show what's going on along the flight tracks. If you want to, you can even fly along with the aircraft to see what's going on. And we do want to develop this so that it does create analysis tools eventually with this project. Now, in the next few moments, we'll begin to transition over to the actual live demonstration. But before we do that, I want to mention quickly what I'm going to show here. So the demonstration is going to show the capabilities that are being prepared for this public release. And you can see the link here at the bottom of the page. One quick note about the link. This is basically the initial public release to it. As the web transition for GHRC occurs in 2021, as we'll kind of move all of our web services into the cloud, we will be getting a more user-friendly web link for this. So hopefully that will make it a little bit easier to work with. At the same time, too, the data sets that I want to work with are coming from the GOESR post-launch test field campaign. There are a couple of reasons why we worked with this. One, I wanted to work with data that were more recent than not. And so some of the more recent data sets are like the impacts field campaign, but we're still kind of ingesting those. So the GOESR post-launch test field campaign gives a nice collection of data that's already archived and already published. At the same time, too, the post-launch test has a variety of data sets, so it really makes it a nice test case to show what is going on and all the various data sets that we can work with. Jennifer, at this point, if we can transition out here, and I can start showing the FCX demo at this point. Thank you, Jennifer. And as we go here, I'll do a quick reload just so you can see what it looks like as we transition, as you first load up the Field Campaign Explorer, and you get to see the, I'm reaching my internet limit at home here. But as you see, Field Campaign Explorer is loading up. And what we started with this particular case is it's loading with everything all at once. Now, let me kind of walk you through the various things that we will see here at this point and the various tools that are available here. So the first thing we kind of look at is I'll start a kind of a full demonstration and a full animation rolling it in a few minutes here. I just want to kind of start with this as a static display just to kind of get things started. So what we're looking at here, the main part of the screen is what we're calling the data viewer. So this is where we can look at the various data sets, we can pan, zoom, scroll around, those types of things. So I want to draw your attention to the upper right. We have a couple of options up here. First, a little kind of search or magnifying glass through here. This is basically if you want to look for some sort of landmark or an address. So this particular field campaign, this is flying over Oklahoma at this time. So we can look for, say, Norman, Oklahoma. And we could do a search for that. At the same time, too, this kind of gridded globe display through here, this is your toggle to go between a 3D or a two-dimensional view of the data. So I'll kind of start off over here. And as you see, I clicked over to this more rectangular look, and this moves us into 2 dimensions. At the same time, too, that does just show that we've moved to a much further out display. So we're not zoomed in anymore. We're really zoomed out. We're looking at a global view. So the question might be, okay, well, how do I get back to there? Well, if you don't remember that off the top of your head, you can come up to the question mark here showing the help options, and we can see how to pan, zoom, and rotate the view. Now, the design has also been kind of keeps in mind that you may be working with a mouse, which is showing the displays through here, or we can also look at the touchscreen options to be able to move around and pan and zoom around through the display. So at this point, I'll work with the mouse right now. I'll work with the mouse commands. So if you want to pan, you just have to kind of left-click, and you can easily just move the display around across the screen. Also, if you want to zoom in, you can either right-click and drag. So one option, you can right-click and drag, and that starts zooming you in. Or you can use the center mouse wheel, and as you would on the web page, you can zoom in or zoom out. Now, if you look at some of the other options, you also have the rotate view. So it can be the middle click and drag, or control left, right click and drag. Before I do that, I'm going to go back up to our 2D versus 3D display, and I'll switch it back to that global-looking one to move us back to the 3D display. And we'll move around the globe real quick and quickly zoom back into the main part of the field campaign observations. Now, the last part is, like I wanted to show, is that you can pan and zoom through this and also rotate. And I'll just kind of very slowly do that through here. That way, as the online display, you can see that as things catch up. And you'll see a number of data sets there being viewed at one time. And I'll kind of walk through those in a few moments here. Even as you rotate around, you can also once again zoom in. And one thing this does I want to draw your attention to as you look at kind of this field here that I'm showing with the mouse, this is the cloud radar system. And what you're seeing is kind of how we work with three-dimensional data sets to help with the data visualization. If you zoom out, we only show a couple of the tiles with that. But as you zoom in, you can see that it starts populating more and more data through there to kind of help fill that in. And you do see that as it's going on at this point. Now, at the same time, too, one of the other things to look at, kind of, again, kind of technical components to look at what we're doing. At the very bottom of the image, we have our playback information. So we can see right here, this kind of this blue dot shows us specifically where in time we are located along the timeline. But we also show that we were at May 17th, 2017 at 05:45 and 40 seconds UTC. Now, if I want to, let me zoom out a little bit here so we can see what happens. I can start the play button, and at this point, the aircraft begin moving at this point, and you'll see the various observations keeping up as it moves along. Now we can speed this up in time, so currently we're moving at 10 times normal speed. I can click on that little bar here, it moves up to 15 times, and just kind of keep moving down the line. We're now moving up to about 30 times, and we'll see the aircraft starts moving much faster. I have to kind of pan and zoom a little bit to keep up with it. And I will pause right now so it doesn't go off the screen and we don't lose it at this point. Now, let's those are some of the technical details that we can look at. Once again, I'll look around, put on the side here, watch what's going on. We can look at the left-hand side as well. I'll first start off with the upper left. And you'll see kind of a little bit of a logo through here. This is the GOESR logo, which is used as part of the GOESR post-launch test field campaign. And you also note, too, as you scroll off and on, when I scroll onto that little pod, you'll see these the little scroll bars will show up so you can easily read. But then as you move the mouse off, those scroll bars will disappear. That's kind of a little bit of feature to kind of help save real estate when you're working with things. But what we've done here is that we're part of the GOESR post-launch test field campaign. I'll scroll down a little bit, and you can see some information about just what was going on with this campaign. There's a collaborative mission. We wanted to verify the advanced baseline imager and the geostationary lightning mapper aboard GOESR, and which is now part of the GO16, which is now GO16. And you can also click on an item called links. So I'll quickly do that. And what this does, this gives us a couple of pieces of information that GHRC has accessible for the field campaign. I'll start with the first one here. I'll go to the landing page. And this immediately takes you to the GOESR post-launch test field campaign landing page. So once again, you get the information about what you need, what was this field campaign doing. If you want to cite the data, so again, this is getting very important as you do publications. We need to be able to cite all of our data sets. Various characteristics, the overall location of where the data were observed, and just kind of go scroll down. You get lots of information about what was going on for that field campaign. At the same time, too, we then get the various individual data sets that were involved with this. So we can look at the GOESR post-launch test cloud radar system. I can click on that. And that takes us to the landing page for that individual data set. So let me close both of those. We'll get back to FCX here. At the same time, too, other links that we can look at. We can look at the microarticle. So again, just more information about what was going on with the post-launch test field campaign, more information, how it was used, scientific objectives, and once again, the various data sets and how they're being used at this point. Again, what we're trying to show through here is that FCX is more than just simply visualizing some data sets. We want this to be an interactive tool where not only can you just visualize data, but it helps you access the data. You can see where we can download the data, what other information is supporting these various data sets, and eventually we want to be able to make this so you can also do analyses of the data as you go here. So I'll go back. I'm going to click the campaign link. That will bring us back to the logo here. And I will kind of start scrolling down a little bit at this point. So what we see through here, there's a link called Display, there's a link called Data, and then kind of scroll over a little bit, a link called Settings. Excuse me. So I'll start with the first one here, is Display. And this is basically just giving you a quick rundown of all the various data sets that are currently available for this particular day. And if I make sure that I scroll up here, we do see that currently we're looking at May 17th, 2017. And the data sets that we see are the Advanced Baseline Imager, some geostationary lightning mapper data. These are very basic. The yellow dots, that's just saying that where the instrument saw light from the cloud. That's all it's basically saying at this point. Or we can do some more complex displays a little bit later. International Space Station also kind of same thing. Where was light seen by the cloud? Cloud radar system, and we give information about what are we displaying, radar reflectivity, the timeline, when were these data available during this flight, and also the legend, what can you see at this point. Now what's interesting here too is that this has the ability to quickly toggle on and off all the various data that you can have. So if we don't want to look at the geostationary lightning mapper or the International Space Station lightning imaging sensor, we can turn those off. And more dramatically, if I want to turn off the Advanced Baseline Imager, I can do that as well. And then you can see at this point that quickly changes what we were looking at. The Advanced Baseline Imager is now not there. We see the cloud radar system once again. We see that we're flying over a little bit south of Norman, Oklahoma at this time. But we can easily toggle that back on if we want to look at that. And also, as you see that loading back up, you see those little squares, those individual tiles that are popping on and on as we're displaying. At the same time, too, I will kind of switch over. If you see the data link, I'll click on that. And this is yet another way that you can go ahead and access data from the Field Campaign Explorer. So I can once again click on the Cloud Radar system. And that brings us right back over to the landing page for these data sets. And lastly, what we can look at is an item called settings. So there's a couple of options for this. Well, the first one is follow airplane. So let me click on that real quick. And what you will see is that will change the view of the aircraft. So now and also that automatically starts our playback. And we're pretty much flying along with the ER2 during this part of the field campaign. And you see the cloud radar system being displayed. We saw those green squares showing up. Those were the fly's eye GLM event simulator. The red arrows, those are the lightning instrument package, showing the electric field mill. So you kind of see what's going on. And it gives you a sense of what's happening as you follow the aircraft. I'm going to turn that off right now. And also what I'm going to do, the next thing that we can look at is the linger time. And before I do that, let me pause the playback here. I'll come back down to the lower left part of the display. I'm going to pause the playback. And the linger time gives us an option of how long do we want to have data stay on the display. So that kind of is pretty obvious if we're looking at, say, the advanced baseline imager. You're going to see the data come up, and it's going to update as it comes in. But for something like the cloud radar system, as we see through here, maybe we don't want to see 300 seconds worth of data. This is equivalent to about 5 minutes. Maybe we only need about 3 minutes of data. We can quickly come over here to the linger time setting, click on that, and that will drop down to 180 seconds. And so now you see we only see about 3 minutes of data. Or maybe you want to look at much more data. You want to see how does that trend look over time. So we can click again on the linger time in seconds. That now comes up to 600 seconds, so about 10 minutes worth of data. And now once again, I'll start panning and zooming around. You can kind of see you have much longer stretch of time of data than we were looking at previously. Now, what I'm also going to show, let me go back to our display setting, and I'll leave this at here. I'll kind of let things start playing back as we're watching through here. As I mentioned, when you look at the left-hand side of the display, if you scroll back up to the left-hand side of the display, you can see the individual dates. So as I mentioned, May 17th, 2017. I'll scroll on down, and then you will see options for the other dates where the ER2 aircraft is flying during the post-launch test field campaign. So I'll click on May 14th. So as you see right now, it quickly shows the same index cards of all the data sets that were available on May 14th. But you will notice, as we look on the data viewer side of the display, nothing yet has updated. That's because we haven't chosen any data sets to look at this point. So I will go over here, and I'll just do something real simple. I'll click on the flight track. And what this does, SCX will then automatically update to to the day that you are active on. So May 14th, and we now have the flight track active. I think this also gives us a good opportunity to look at what do we see on these various little index cards, for lack of a better term. I've already mentioned the availability, see what the data looks like, the toggle on and off, and the title for it. But you'll also see in the upper left these little icons, an aircraft, a little satellite, and these are showing where the type of observation that you're looking at. So you can quickly tell at a glance, this is a satellite data set, this is an aircraft data set. And once again, since it's kind of the most photogenic of data sets, I'll put on the cloud radar system. We see, again, it's an aircraft through here. And we see at this point, we show a quick little display pop up from that. Once again, I'll kind of pan around, and then I will start zooming in, be a little bit closer to what we're seeing. And once again, you'll see that dynamic update as we zoom in and it fills in. I'll come down to the lower left-hand side. I'll kind of slow this down to about 2.4 times, and then hit play. And once again, you'll start seeing the aircraft flying along, and you'll see how the cloud radar system starts filling in as you go forward there. If you want to as well, you can come down to the timeline and you go either forward or backward, and I'll just do that. I'll back this up a little bit of time. And since I moved this back quite a bit of time, I will zoom out. And we can see where the aircraft was previously at that point. I moved a little too far back in time, it looks like. Now, the last thing I want to start kind of showing you, showing some of the playbacks, some of the settings that you can work with, shifting to different days. The last tool I want to show right now is the timeline tab. And before I do that, here we go, you see us updating there. I want to go back to our first day, which was May 17th. Click over here, and you get the Cloud Radar system back on, and make sure the navigation is back on as well. And I'm scrolling down, going back to the flight track, and now we come back to our original date, May 17th. I'm going to zoom out a little bit, pan around, and what I want to show real quick, just next to the data viewer option is the timeline. What we can click on here is this is an option to visually show what data sets are available at what time throughout this case. So you see through here the total flight time for the aircraft on May 17th, just before 1 UTC, all the way out to just after 10 UTC. And as I bring in more instruments, I go to the left, I'll bring in the Lightning Instrument Package, Fly's IGLM Event Simulator, Cloud Radar System, Geostationary Lightning Mapper, and then finally the Advanced Baseline Imager. You'll see each one of these data sets when it was available, both for the flight and the instruments during that flight. At the same time, too, I left out, I can put in the International Space Station Lightning Imaging Sensor, click on that, and you'll see that the overpass for when that occurred during the flight. And so with that, Jennifer, if we can switch back over to the presentation display. Thank you very much. So I just want to kind of wrap up here with kind of the future efforts of what we're aiming for here. The main issue that we're looking at going forward, particularly the next year, is migrating the Global Hydrology Resource Center's web capabilities into Earthdata Cloud. That's going to include Field Campaign Explorer, the website, and our various Lightning tools to work with this. Also, we want to make sure that we keep developing cloud-native data services. So that means continued enhancements to the Field Campaign Explorer, such as data analysis, improved data discovery, and also we've done a lot of work to display these data in the cloud with Field Campaign Explorer. What I'd like to do from the outreach side is to start trying to take that expertise and develop that into data recipes for individuals. They can start displaying data and working with these data online and in the cloud as well. So with that, I'd like to thank everyone for their time here today. We won't do questions immediately. I'll hand this back over to Jennifer, and she will help us walk through the final part of the presentation here today.
Okay, great. Thank you, Jeffrey. At this point, we will transition to the final optional set of polling questions. We'll give these about 3 to 4 minutes or so, and then from there, we'll transition to the question and answer period. All right, thanks, everybody. Okay, we're going to give these just another minute or so, and then we'll move directly to the Q&A period. Okay, everyone, at this point, we will transition to the Q&A. And our first question was asked actually pretty early on, so either Jeffrey or Will. a compliment about, comments about wow to the archive growth, but how much control and security can a cloud-based storage provide vis-a-vis self-owned secure servers? Logistical nightmare maybe, but then is security really better? Won't access be slower too? So either Jeffrey
Will, I think I will. Will, I think that's probably in your wheelhouse here, and I know you've been working with some of the security features on that, and so I will defer to you here.
Okay, no problem. The answer is that it is treated, the data in the cloud is treated exactly the same. NASA treats that data the same way, whether it's in the cloud or whether it's on-prem. So it goes through NASA firewalls before anybody can access it. It's treated exactly the same. Speed-wise, we've even done tests between on-prem and in cloud, and there is no speed degradation from accessing data from in the cloud.
Okay, great. Thank you, Will. The next question is, will the Field Campaign Explorer be available for datasets hosted by other DAACs?
So Jeffrey mentioned that we are in transition into Earthdata Cloud for the Field Campaign Explorer. We expect that to happen over the next month and a half to 2 months. And once we're done, we will start looking at what other data sets to start including. We would initially be looking at cloud data sets. And so the answer to that is yes, we do have plans to look at that.
Okay, thank you, Will. Just a moment ago, I had added some links down in the bottom right. And so those links will be available when we're finished. It's a persistent feature. So if you listen to the webinar later, you'll still be able to interact with those links, and you can always feel free to email me with any questions or to send them to you directly. Okay, moving on to our next question. Is the Field Campaign Explorer combined with programming languages such as Python? While data download is nice. Whoop. Okay, let me go ahead and finish. There's a little bit of a comment. That's okay, no problem. Is the Field Campaign Explorer combined with programming languages such as Python? While data download is nice, a tightly integrated coding or viewing environment like Google Earth Engine would really boost scientists' productivity.
Okay, so the backend is built on Python, and while we aren't using Google Earth, if we do add it, it would involve an additional development aspect to it. It's not in our current roadmap, but that's not to say it can't be.
Okay, thank you, Will. The next question is, since GHRC has migrated all data sets to the cloud, is the data currently available to the general public user from the cloud? And if not, then when will it be available?
So the answer is yes, it is currently available in the cloud. All of our static data sets were migrated several months ago. And if you go to Earthdata Search Client, you can access all those data today. In the next sprint, in the next 2 weeks, we'll be working on updating Hydro, which is the GHRC's search client, to point all of our static data sets to the cloud. And so whether you're using our search tool or the Earthdata search tool, you will be looking at cloud data sets. Followed shortly thereafter, we will be updating the near real-time and ongoing data set to be pointing to the cloud as well. And that will happen within by the end of the fiscal year for sure.
Okay, great. Thank you for that. And I've added the Earthdata Search Client link into the Q&A pod as well. The next question is, on FCX, is aircraft altitude displayed?
It is not. We do.
No.
Go ahead.
Oh, I'm sorry. I was going to say, at this point, no.
It can be added. We do have the information, obviously, to do our plotting. So it is a feature we could add if that's something folks want or need.
Okay, well, thank you to the both of you. The next question is, any thoughts about using FCX as a field campaign planning tool?
I will let Jeffrey answer that one.
Yes. In fact, its origins came from the hurricane and severe storms field campaign, the HS3 program. I think I got the name slightly wrong there. So it did work and evolve out of that. We definitely would like to have users, if they're interested in working with it, to be for their campaign planning. I know that was something that we discussed a little bit with the Impacts Field campaign this past year when they were getting ready, but they had selected a different system to work with for their various planning purposes. So yes, in the future, we would definitely like, if there's a need for that and an interest in that, we'd definitely like to do that. Kind of as a follow-on to that as well, one thing that I'd like to eventually kind of see happen is when you're kind of looking for data, trying to visualize data, I'd like to kind of see FCX help you kind of say, okay, I want to download a data set, but I know what I want, just what time do I want to look at? And many of us, if you're trying to do some sort of research, you're always kind of hunting around trying to find a data set and find that particular time frame that's just right to get the information. And I hope that we can get to the point with FCX as well that we can try and evolve that so that it is also kind of a visual interface for many of the high-profile holdings at GHRC.
Okay, thank you, Jeffrey. The next question is it possible to adapt or integrate to an ArcGIS platform?
That is something I think we'll have to go back and talk to our developers and our architect for that. I think that has definitely been something that we have heard in discussions of not just Field Campaign Explorer, but other data sets. How can we integrate this into ArcGIS? And that seems to be a broad question from the community as a whole. And unfortunately, I don't have a direct answer to that, but we definitely want to take that back to the developers and see what can be done with that. A quick moment and just once again thank everyone for their attendance. I appreciate their questions and really interested in hearing what they've had to say, and thank you very much for attending today.
Okay, we do have one more question that just came in. Is the development of FCX open or closed source?
We are in the process of making that open source now.
Okay, great. All right. So at this point, if there are no further questions, what I can actually do is go back to one layout and leave the links open for a few minutes for those of you who might be interested. Again, I can always send them to you. There's a link to 2 recent data chats for some of the team leads working on these cloud evolution efforts, as well as a link to the DAAC website and other resources. So thanks to all of you. We'll log off from the audio component, and I will leave the virtual meeting space open for an additional 10 minutes here or so. All right, so thanks to our speaker, Jeffrey Stano, and also to our Q&A panelist, Will Ellett, and I hope to see some of you at a future webinar. All right, thanks everybody. Goodbye.